Yeah. There we go. So, what I want to talk about real quick is, how many of you guys keep chickens? A few of you? A couple of us, this entire row, that's interesting. So, we decided to have chickens a few years ago. They're in their third year now, and apparently they're getting older. It's amazing. I thought I had at least 4 or 5 years out of them. They're all like molting and not laying, or when they do lay, it's like missing a shell. It's adorable. So, but 3 years ago, we went to the store, took Max to the store, and we said, buddy, go in there and get 4 chickens. And it was adorable because he picked 4 different styles. He picked, which I thought was great because it's all apart there, which is great. So he picked a Plymouth Barred Rock, I think they're called, a Delaware, an Americana, and then tucked under there is the Orpington. No, that's the Americana, that's the Orpington. Yeah, okay. Yeah, so here's a better picture. Americana, Orpington, Delaware, and there's Bertha, the Plymouth Barred Rock. Here's a better picture of the 4 of them. So that's Mary the Delaware, Nancy the Orpington, Bertha the Barred Rock, and Marge the Americana, named after our grandmothers. And which is adorable because the 2 that are my grandmothers hang out together sometimes, and the 2 that are Jen's hang out together, which I find fascinating. But here's the deal, right? So we go in the store. I say, Max, go find some chicken. So they give a little box, like a little Happy Meal box, and you know you throw these chicks in the box. You go to the counter and give them like $4 or something, and eat a bag of food for like 16. And they go, okay, cool. And I'm like, okay, so I noticed that some of them back there, they have fryer on the label. I'm like, what's that? They're like, oh, that's a meat chicken. Oh, that's cool. That's cool. And these are called pullets. And I was like, what's a pullet? And he said, well, pullets are females. They're females. The idea is you get pullets and they're going to lay eggs for you. So you're not going to. These guys aren't designed to get big and fat to eat. Like I guess like a fryer, the idea is you fatten up for like 10 months and eat them. Pullets, or I guess these guys, whatever they're called, pullets, are designed to just lay eggs until they can't anymore, and then get old and poop everywhere and eat your vegetables. So we bought 4 pullets, and I said, oh, that's cool. And it's something the way he said it kind of caught me off guard. It's like the way he said it just made me question. I'm like, so when you say they're like designed to lay eggs, like, yeah, some won't lay eggs. I'm like, oh, is it like a genetic defect? He's like, no, some of them are boys. I'm like, oh, some of them are boys. Okay, so how do you know when they're boys or girls? They're 1 day old, they're this big. You like lift their skirt and look underneath? Like, how do you, he's like, well, they've been sexed. I'm like, okay, but you just admitted that there might be a boy in that box. And then he gave me this statistic, which I thought was interesting. The chance when they sell you a female chick that it's actually female is 90%. So that's what he told me. He's like, sexing is 90% effective, which means that in this store, where there were hundreds and hundreds and hundreds of little peeps, it was actually a very soothing sound. It's like kind of like when the tree frogs come out in the springtime. You think it's going to be totally insane, it's actually very, very relaxing. So you walk in the store, these little tiny muffled peeps from all these little Rubbermaid Tupperware bins. 90% of them are girls and 10% of them are boys. So I held up the box that Max had just purchased, which is now half full of poop. And I said, so there's a 33 1/3 chance that I got a rooster in here. And he kind of looked at me and shook his head. He's like, what do you mean? I'm like, well, you just told me that there's a 90% chance that each one of these girls is a girl. That means there's a 10% chance that each one of these girls is a boy. That means there's a 1 in 3 chance that I'm holding a rooster in this box somewhere. And he was like, how the hell do you know that? And I said, I'm diseased. And then I sat down and gave him a quick lesson in probabilities. Oh, nice. And he loved it. He was like, that's pretty awesome. It's totally awesome. But I asked him, where did you get your 90% from? Because I was interested in that, and he said, well, that's what my breeders tell me. I was like, how do they get it? And he's like, he assumes they just count. And when he hears complaints about, you know, oh, this one came back, or this one came back a boy, this one came back a boy, they just add it into the data mix. It seems like a very hard thing to track, though, yeah? Mm-hmm. And I've often looked at Craigslist and seen there's always a rooster getting given away. Take my roosters, you know, kind of thing. Now these girls turned out girls. They've all been laying eggs ever since we got them until about 3 weeks ago when they decided to stop. That's okay. But I got curious. Can we use this information to kind of help us design our chicken flocks? So that's what I want to do today. But we have to come to some understandings first. First of all, so this is kind of what it looks like. Imagine this times like 10, though, in the store. And imagine bigger bins, because High Desert Ranch have had bigger bins full of these little tiny. The best time to go is the first day they get them. Because I just heard one. There it is. There it is. Wonderful.
What are you doing in your pocket?
So it's a wonderful, wonderful thing to experience. But here's the deal. I need to ask you a couple questions first. If Max is going and grabbing chicks, should we call that independent or dependent sampling? Now I'm using terms from your last project because I'm a bastard.
Independent.
What? I agree. It isn't really, though, is it?
I would say dependent.
It is dependent, yes, but wouldn't we want to make it independent?
Yeah.
Why? Why would we want to make it independent?
You're only considering
Independent.
Say that again, Christina.
because we're only talking about the probability within the set of girls.
Very nice. But mathematically, why would I like to keep it? You got it contextually perfectly, by the way, thank you. But mathematically, why would I want to treat it as independent? Think of the pumpkin seeds from the last project, which is this is essentially the exact same thing. When you plant a pumpkin seed in the ground, one of two things happens, yes? It germinates or it doesn't. What was the chance of germination, do you remember? I think it was a 40% don't germinate and 60% do, I think, right?
Yeah, that sounds right.
Pretty close to a coin flip, right? 60-40. This is the same thing. If you think about it, Max grabs a chick and it's either a girl or it's not. It's either a girl or it's not. Does that make sense? A very interesting thing happened, and I'll bring this back next week. A former student sent me a scathing email about how, you know that 1 in 10,000 chicks are born with sexes of both parts. I'm like, no, I didn't know that actually. Thank you for letting me know. She's like, well, you need to adjust your math problem to adjust for this. So I was like, I did, and then I sent it back to her. And it changes almost nothing. It changes almost nothing. It changes it by like a 10,000th of a percentage. But it was very interesting. It gives me the idea that the internet is changing the way we react to each other online. Like that discussion could have gone so much more pleasantly.
Yeah.
Like, hey, have you ever heard that certain chicks are born with boy and girl parts? Hell no, I haven't. That's really interesting. Maybe we should adjust that, with our... Anyway, come back to that. I want to talk about this independent-dependent sampling thing, though, a little bit. Why would we want it to be independently sampled? Why is the mathematics easier if it is? That's okay. Let's figure it out. Let's figure it out.
Because we don't have to, well, first of all, we don't have to count every single chick.
First of all, very important, yes. Secondly,
Secondly, we're assuming that the probability is still 90% regardless of how many chicks he pulls out of there.
grab your TIs real quick. Let's do a quick math exercise here. Yes, that you nailed both of them on the head right there, Madeline. That's exactly why we want to assume independence. But we have to make sure we can buy that it should be independent, because it really isn't. As Danny pointed out, it's actually dependent sampling. But I want to make it independent sampling. All right, let's fire this up. So, the chance, let's pretend we're Max going into the store. So pretend you're 2.5 feet tall. He reaches in and he grabs a chick. What is the chance that chick is female?
90%.
90% according to the guy working at the desk. Now, let's suppose that, I'm going to guess there are about 700 chicks in that store. There were hundreds of them in that store. Let's make it 1,000, just make it easier. Make it 1,000. No, make it 700. Make it 700. If there were 700 chicks in the store, that means, looking at it a different way, Max would have a 630 out of 700% chance, or a 90% chance of grabbing a chick. Then he takes that first chick, puts it in the Happy Meal box, hands it to Dad, Dad holds it, Dad says, Max, go get a second chick. He reaches back in the bin. What is the chance that that next chick is a female? I hear a lot of 90%.
But
Isn't it technically now, bear with me here, it's going to sound annoying. Technically, isn't it 629 out of 699?
yes.
Technically it is, right?
Yep.
But look at what that is.
Yeah.
Isn't that essentially 90%, yes?
Yes.
Now, he takes second chick, puts second chick in Happy Meal box.
And we can't use that number.
We can't use that one again. He goes back in. What's the chance the next one he buys is a girl?
0.897.
Isn't it 628 out of 698?
Still 0.9.
Which is essentially 0.9, 90% yes. And then he puts Happy Meal box, goes back in, and the next chick is 627 out of 697. You see what's happening, friends?
Yes.
Granted, it is not independent sampling, because we're not putting the chicks back each time we pick them up and take them home. That's the whole point. But can we pretend as though it were? Yes. So long as what? There's one big so long, and this is something I mentioned in the project too. So long as, say that again, Renee. As long as there's a lot of chicks in the store, and how many are you buying?
Just a few.
Just a few, thank you. That was perfect. So long as there's a buttload of chicks in the store, and you're only buying a few. Now, if you want a definition for what a few should be, here's a nice kind of a guideline for it, as long as you're sampling less than 5% of the total. Keep that in the back of your mind. Don't memorize that. Don't memorize that. We'll repeatedly say that over and over again. As long as you're sampling less than 5% of the total, then you're going to stick around the independent probabilities. You're not going to get too far from it. Okay? That's just a guideline for later on when you're actually doing your own statistics in your classes. Because we want to do this independently. The mathematics becomes much easier because we can use 0.9s and 0.1s. I don't want to use 0.89569. I don't want to use that crap. I don't want to change it each time. Sometimes you have to. For example, if we have a small population and we're choosing most of it, then you have to go back and use what's called the hypergeometric distribution, which is totally freaking rad, but I'm not going to torture you with it in this class. Okay? We're going to keep it binomial, which is what this bad boy is. Tiff, go.
If it's over 5%, can we lean towards dependent, or should I say something
You-
different?
Honestly, you should lean towards dependent, and that's with a hypergeometric distribution. FYI, on the quiz you guys just turned in, the in-class quiz, there was a section at the end where I said, if you can figure out where I got these probabilities from, I'll give you extra credit points. If you're still interested in trying that, by all means try it. I'll send you another copy of the quiz via email if you want. That's where you have to use the dependent sampling idea in something like that, because there's only 80 and 20 are being pulled. You're pulling 25% of the population out. So you can't treat them independently. You have to use what's called the hypergeometric, which is, again, totally freaking rad, but not worth getting worked up over right now. Is that a fair argument?
Sure.
So, I guess what I'm getting at is we want to use this, we want to use this as independent sampling. So we're going to, it's independent enough. It's independent, it's the same thing Gallup does. When Gallup goes out and surveys 1,265 Americans or something like that, they essentially do it independently. But they treat the numbers as if they weren't, because they're grabbing 1,200 Americans out of 300 million, 311 million. They're touching such a small number that one removed is not going to change it one way that if you count it or don't count it. Is that fair?
Yeah.
Good. So we're going to treat these situations as such. What's the chance we get all hens? Well, I answered that question for you already. It's about 2/3. Because I told you there's 1/3 chance I got a rooster, yes? Mm-hmm. There's a 1/3 chance I got a rooster. So how did I get 2/3? We'll come back to that. What's the chance I got all roosters?
Pretty low.
Pretty low. It's not 1/3, right? 1/3 is a different answer than that. That means I got a box with 4 boys in it when they should be 4 girls. So it's pretty low, but how low is pretty low? We'll come back to that as well. What's the chance we get 1 rooster and 3 hens?
Pretty fair.
Pretty fair. Like that answer. Okay? But again, these are all hms right now. What's the average number of hens we should get? Every time I send Max into the store to buy 4, on average, how many hens should he be getting out of that box? And while we're at it, what the hell? Let's talk about the standard deviation around that too. While we're at it. These are all I'll have this posted for you guys. You don't have to write this stuff down if you don't want to. Please, Danny.
Why are we using sigma?
Because we're having, if his number of 0.9 is accurate, this is a great question. You guys hear this? Why are we using sigma and mu for that matter, yeah?
Oh, thank you.
Thank you.
Thanks for saying that.
Yes, it's a great question. Ask him frequently. If this guy's assertion that 90% of the chickens are female, that's a global measure. I mean, he's applying that to all chickens that I can buy from his store. So it's global, it's a parameter. It becomes a parameter, so I can call it mu and sigma, yeah?
Okay, cool.
And we're going to make a distribution out of it, which means it's inarguable, yeah? Fair? Is that a great question? Please ask it frequently. It's a very, very good one. Okay, so what I want to do first, say that again. Say that again, please. Andre, say it again. It's important to hear. Say it again.
Oh, he was just asking whether this whole thing is independent or dependent, but what I told him was that technically it is dependent, but we're treating it like independent.
That cannot be heard enough. Honestly, we are.
Yeah.
This is not an independent event because Max has not put the chicks back. But we're going to make it independent because it makes the math easier and we don't lose the accuracy. Remember how I told you that student sent me the scathing email about the 1 in 10,000? even putting the 1 in 10,000 in and making this a trinomial experiment where you've got boys, girls, and both, the numbers of the both that included the both were so low, essentially they were exactly the same results as this. Of course, this is a little bit inaccurate because of that, assuming that 1 in 10,000 actually are both. But that doesn't change the numbers. They still round to 4 decimals the same exact way. That's the point. That's the point. It's close enough. Good, thank you. That again, cannot be said enough either. Let's build some flocks. Okay, we're not going to build the 4 flock right away. I've learned in the past it's not a good idea to jump right to the flock of 4. We're going to start by buying 1 chick. We're going to buy Bertha first. All right. So let's build. I'm going to stop and start the camera again too to get this together to restart.
Can you bring